morning, esteemed dignitaries, honored guests, respected faculty members, and dear students. On behalf of the Institute of Chemical Technology, Mumbai, in association with the UDCT Alumni Association and the Catalysis Society of India, it's my great privilege to welcome you all to this symposium commemorating the 75th birth anniversary of late Professor R.A. Rajadhaksha, a visionary teacher, an eminent researcher, and a pioneering figure in the catalysis and chemical engineering at ICT Mumbai. Today's event celebrates his remarkable contributions to the catalysis and chemical engineering and aims to promote continued discussion on sustainable catalytic processes for the future. I would like to warmly invite our distinguished dignitaries, Padma Vibhushan Professor M.M. Sharma, Padma Bhushan Professor J.B. Joshi, Chancellor ICT, Professor A.B. Pandit, Vice Chancellor ICT, Dr. M.G. Palekar, and Professor Chaskar to kindly come forward and take their seats on the dais. I now invite Professor Atul Chaskar, Head Department of Chemistry ICT, to deliver the welcome address.
Good morning, everyone. Dignitaries on the dais, my senior colleagues from industries and academia, and dear friends. It gives me great pleasure to welcome you all for this special occasion. On behalf of Institute of Chemical Technology, UAA and Catalysis Society of India, I welcome you all for this one-day symposium on catalysis for sustainable development. This event holds special significance as it commemorates the 75th birth anniversary of late Professor R.A. Rajadhaksha, a remarkable individual and exceptional academician whose contribution continued to inspire generations. Though he left us far too early, his legacy in the field of chemical sciences and catalysis live on. We are gathered here not only to delve into the evolving landscape of catalysis for a sustainable future, but also to honor the memory and impact of a truly revered soul. Let us make this day meaningful, both in a scientific spirit and heartfelt remembrance. Thank you.
Thank you, sir, for your kind words and for your continued leadership in advancing research at ICT.
Good Good morning, everyone. So, for the floral welcome, I request Dr. M.G. Palekar to kindly present a bouquet to Professor M.M. Sharma. I request Professor Dilip Chaudhary to kindly present a bouquet to Professor J.B. Joshi. I request Dr. Shrikant Karwa to present a bouquet to Professor A.B. Pandit. I request Dr. Mayuk Vadavekar to kindly present a bouquet to Dr. R.V. Jasra. I request Dr. Ashish Chaudhary to kindly present a bouquet to Professor Parag Gogate. I request Dr. Manoj Kharkar to present a bouquet to Professor Atul Chaskar. I request Dr. Manoj Kharkar to kindly present a bouquet to Dr. R.V. Chaudhary. Thank you, esteemed dignitaries. For the inauguration of this symposium, I kindly call upon Professor A.B. Pandit, Vice Chancellor ICT, to address the gathering.
Good morning, everybody. Padma Vibhushan Professor M.M. Sharma, Padma Bhushan Professor J.B. Joshi, Professor Chaskar, Dr. Palekar, Dr. R.V. Chaudhary, Dr. Jasra, all those who have had some association, Rajiv Pandya, all those who have had association with Professor R.A. Rajadeksha has come here to celebrate what would have been his 75th birthday. I'm extremely fortunate that I had an opportunity to learn one subject of analytical techniques in MChem engineering. And it is quite fortunate that my colleague, Dr. M.G. Palekar of the same batch, we joined. I selected Professor J.B. Joshi as my guide, and Dr. Palekar chose R.A. Rajadhyaksha as his guide. So effectively, both were his first PhD students, so to speak. It's a coincidence that today, 14th of October, Sachin, tikade bas. Today, 14th of October, happens to be also birthday of Dr. M.G. Palekar. So, he not only shares a Guru-Shishya relationship, but he also shares his birthday. In our time, the PhD candidature, PhD working was quite different. We were, though belonging to different guides, were a very cohesive group, and that group is still very much active, and I see almost everybody from that group. And the group is called as UDCT Cricket Group. For the reasons known, because cricket was Dr. R.A. Rajadhyaksha's favorite sport. He used to participate regularly. He used to play matches, especially those 20-over games which you play in England, starting in the evening at 5 o'clock and going on till 9:30, 10 o'clock. Have a glass of beer after that. So he was one person who was very friendly with the students, never treated his students like his students, but his colleagues. We used to have nicknames for everybody. Professor M.M. Sharma was popularly called as Mama. Professor D.D. Kale was popularly called as Dada. Professor K.K. Tiwari was popularly called as Kaka. And R.A. Rajadhyaksha, as everybody would say and became very popular, was known as Raja. And he was that kind of a personality. And I'm extremely happy that all of his students, along with me, have taken this lead and have come together today to celebrate his legacy, his fond memories. I still remember that, to the best of my knowledge, mine was the last marriage which he attended in July before he went to France, and on his return, this unfortunate incident happened. I had a very fond memories. I had taken my wife to meet Professor Rajadhyaksha before marriage when she was visiting UDCT in his room along with Professor Kumar, and I still remember the conversation which we had at that point of time. I'm purposely reliving those memories because he was one of us for all the students' activities which we were involved in. But at the same time, he was a brilliant teacher. Just because he was an outstanding teacher, I think it was very apt that the students came together and decided to initiate Professor R.A. Rajadhyaksha Best Teacher Award. And the key factor of this particular award that it is not decided by anybody else but the students only. So it is chosen by the voting of the students, especially the final year students. And Dr. Karwa will announce few things in the light of that. But what I am going to say today is I am very happy and delighted that all of you have come together, and in his honor, we have decided to not only celebrate his great legacy as a catalyst, but also as a good human being. He is an ideal guide how to be with students, be among the students, and yet guide them to get best out of them. So I am very happy that you all have come here, and I'm grateful that we have a registration of more than 139. I'm sure many people will join a bit late. Bombay traffic is always unpredictable, so I'm sure we will have great deliberations, great memories, great remembrance, and celebrate this as a day to remember. Thank you.
Thank you, sir. I would request Dr. Mayur Paravdekar to present a memento to Professor A.B. Pandit. I would like to invite Professor J.B. Joshi, Chancellor ICT, to kindly address the gathering.
Most esteemed and most revered teacher of all of us, Professor Sharma, all the dignitaries on the dais, Rupavahini, Sachin, Raja's students, and all other delegates. Good morning to you all. We were colleagues. For undergraduate, I was 1 year senior to him. Professor Chandalia used to teach us chemical reaction engineering, and I did very well in backmixing and residence time distribution, so I became his favorite. So for the next batch, the batch doesn't know, but he assigned me a work of correcting the home assignments for chemical reaction engineering. While looking at those assignments, I quickly realized that here is something different. This assignment is something different, totally different. And needless to say that he became first in the final year engineering. And he broke all the records of 1933 to 1972. And the difference between his marks and second best was 18. Such a huge difference. He told our sir, Professor Sharma, that he wants to work in the area of catalysis. He quickly organized, he talked to Professor Doraiswamy and Professor Vasudeva and fixed him for the subject he wanted. He completed his PhD in 3.5 years. I took 6 years. There was a reason, of course. I was teaching simultaneously. BK means one complete course, MK means one complete course, third year chemical engineering, one complete course. On top of that, 2 laboratory sessions. And I was doing research only on Friday, Saturday, Sunday. But that doesn't mean anything about the greatness of my dear friend. So he completed, became engineer in 72 and completed his PhD in early 70s, 3.5 years. And then he went for postdoctoral under the guidance of Professor Kimball and Professor Anderson. He returned in 79 and such a Professor Sharma and Professor Doraiswamy, it was needless to say that he was going to become a rarest teacher, rarest researcher, and rarest industry advisor. And there was a little happy, you can say, Professor Sharma wanted him here, and Professor LKD wanted him in CSIR family. Finally, Professor Sharma, he won, and Raja was here. And Raja was appointed as a reader. During that period, I was in US for postdoctoral. So see Professor Sharma. He appointed him as a reader. I was senior. But he nominated me for INSA Young Scientist. And he did not nominate Raja because all his publications were from England and Australia. It's difficult to imagine now that such a fearlessness and the choice. Sorry. Looking at the overall personality, I would rate him among the three as the best teacher. And as Professor Pandit told you, award was instituted in his name, and Professor Pandit got Rajadhaksha award 15 times, consecutively 15 times as a best teacher. But at that time we had started worrying that after Professor Sharma, so we friends were considering Raja, but he was too junior, how to consider him. But he became professor of chemistry in 1985, I think, if I remember. And that made him the university rule favorable that he would be the senior most professor at the time when the directorship was to come to ICT. Professor Sharma was making both of us familiar with so whenever there were presentations to UGC or INSA, he would take both of us to Delhi, stay in INSA guest house. He was there himself, but he would make me or Raja to make a presentation on behalf of ICT. And his message to us was, if your cause is noble, be fearless. Don't be afraid of anybody who is sitting in front of you. I told Raja that you visibly look fearless, so you don't need advice of Professor Sharma. But I need to be fearless. See the friendship. What Raja said, JB, you are also fearless, but you are fearless inside, not looking fearless outside. If you take anything to your mind as an activity, you will take it up to the end. See the confidence that a friend gives to a friend, where colleagues were so-called competing with each other. But I don't think we had any element of. Two incidences I must tell you, which confirmed that he should become director, and he would have taken our UDCT to much greater heights. He finished his PhD thesis in 1976, and obviously, as usual, there was a viva voce examination. After the examination, he took Professor Sharma, Professor Vasudeva, the examiner, everybody for the lunch. You see, we all of us were afraid of. He was not. He was fearless. He took them. Professor Sharma had one very strong feeling that the directorship of ICT, UDCT then, should not come by seniority. Until he became senior, he waited. And at that time, he wrote a strong letter to university, don't make me director because I'm senior. Then myself, Raja, and one or two people at that time, we made a small group to convince that he should become director. So, we respect Professor Sharma very much. So, whom does he respect and listens to? If he says something, we act 100% accordingly. But who respects him? It was very simple to recollect that Professor Tilak and Professor G.P. Kane were the right persons. See the courage. He was the leader, and we went to these teachers, and rightly so, the positive answer came at the end of that. Why I told these two incidences was, apart from teaching, apart from research, he had the courage and fearlessness to take such big tasks. I'm his friend. I can talk on and on, but I'll stop here. I congratulate and give my huge compliments to those who have organized this program. Great. Thank you so much.
Thank you, sir, for all those heartwarming words. I request Dr. Pramod Kumbar to kindly present a bouquet to Mrs. Rajadhaksha. I request Mrs. Joshi to kindly felicitate Mrs. Rajadhaksha. I request Dr. Manoj Kharkar to kindly present a bouquet and memento to Mr. Sachin Rajadhaksha. Today, we are deeply honored to have with us Padma Vibhushan Professor M.M. Sharma, former Director of UDCT and Emeritus Professor of Eminence ICT, to deliver the keynote address. Professor Sharma's unparalleled contribution to chemical engineering and catalysis has inspired generations. Please join me in extending a very warm welcome to a person whose legacy is etched not just in academic papers but in the success of an entire industry.
First of of all, let me pay tribute to the genius Raja. And I'm very happy to see Rupa and Sachin. They were my neighbor in the staff quarters. I've seen Sachin as a little boy. He looks different now. But when he was small, he was like a almost carbon copy of Raja. With the pictures that were displayed before you came, one could see the striking resemblance between Sachin and his dad. My memory goes back long time ago. It was very interesting, J.B. Joshi told you about some anecdotal part, but I want to tell you something more. My dear friend Doraswamy challenged me that as I was called, try Raja. So I counteracted. So I said, you also try. How we won him over was very interesting, because his mind was split between NCL and UDCT. I said, when you develop catalyst in NCL, it will be called NCLite. When you develop in UDCT, it will be called Raja Catalyst. 2, we'll make you consultant on day 1 on catalysis. And first time, Hindustan Organic Chemicals has an outsider, not institutional consultant, which NCL was Raja. And there was a catalyst for aniline, which became inactive after some time, and the institutional consultants could not solve the problem. I knew that Raja had capability of reviving this catalyst, and he did. When he joined us, I want you to know that first major, most expensive equipment that came in Cambridge was his FTIR. And at that time, Swiss currency, Indian currency was depreciated. So we had problem because cost went up by 3-4 lakhs of rupees. I don't know, finally it probably cost 21 or 22 lakhs of rupees, big sum. 28 lakhs finally. But it happened. What is unique is he is a rare chemical engineer who went and worked with physicists, then chemists, and then took full training in spectroscopy. It's a frightful combination for anybody working. I don't know many people in India who have had this kind of background, and then the science and practice of catalysis. This is what made him unique. I will never forget, I was on a trip abroad. I came, actually it so happened that I was leaving Paris, same time he was leaving Paris for India, I was going to South America. When I came back, my wife was in deep shock. And she said something which rattled me no end. Anyway, there is something called destiny. Many of my colleagues would know that how frequently I refer to Raja. That he would have got Bhatnagar Prize, he would have become Fellow of INSA, for sure. Anyway, man proposes, God disposes, so to say. One anecdote about, he used to come to me and discuss catalysis. I used to have some old notes, and he would sort of very innocently ask me. So one of the rare occasions when I told him, I said, you are taking great interest in Rennie catalyst. I think many of persons who worked with him, he used to consult with that chap, ex-UDCT fellow on Rennie catalyst. So I said, Raja, do you know, Rennie was a mechanic, and he gave a definition of catalysis: a hammer which drives a nail comes back unharmed. Oh, is that so? I said, that is in record. That is how Mr. Rennie, whose catalyst and became generic name Rennie Copper, Rennie Cobalt, he described in his vein as a mechanic. I will never forget my association. It became even closer because he was neighbor. I mean, at a personal, and he used to host parties for his classmates and some of his. I'm not seeing Anand Apte and there, and these people. I didn't want to interfere in their merrymaking, so I used to just go for 10-15 minutes, just cross my flat to his flat. But he was a great guy. He used to smoke. I used to tell him, rather don't smoke. But I think he couldn't give up, I think, till the end. Anyway, I'm very happy that we have the hall is nearly full, and that Anirudh Pandit, fortunately I had relationship with all his students. I think for some reason or other, I think I used to pass on some chits to you guys, no? I think something I'll pick up and say, pass on. I was called Chit Sharma, Yeah. Okay. Very nice to see. And I'm particularly happy that these people got together, gave handsome sum of money for the first time in history of UDCT to create an award for best teacher selected by students. Can't blame the management of UDCT to select someone, because it was all on the basis of voting. But that is all for Raja. Once again, my tributes to him. I'm seeing Rupa after 91 first time. I think my son hosted them in Houston. I never had that pleasure of hosting them in the flat. Okay, I'll now come to the subject proper. And I start by saying catalysis is an astonishing phenomenon. Real astonishing, because it's magical. Look at number of Nobel Prizes that have gone to catalysis, from Oswald to Haber and in the most recent past, metathesis. Metathesis itself is a very charming, very difficult. I have called, dancing of molecules, chopping and stitching of molecules, something you can't imagine. Started with propylene being in excess to go to ethylene plus butene, and exactly reverse is practiced on a grand scale today. Kind of conversions it is able to do, catalysis is able to do, is sometimes unbelievable. I like to give you just 4 illustrations, but before that, apart from Nobel Prizes, you look at the number of journals in catalysis. Even Nature Catalysis is there now. Catalysis communication, catalysis letter, applied catalysis. My God, I think it's not easy to cope up with all the journals in of course, the oldest journal catalysis. But it's fun going through. And there are a number of groups in India. And one of my common comments, which RV would remember, you all said, commercializing is a different game than publishing. We also did some work. G.D. Yadav is not here. We were the pioneers in doing work on phase transfer catalysis. He was the first person, not chemist. We were also the first one to work on cationic ionization resins as catalysts and commercialize them on a fairly large scale. Rajiv Pandya is here. His company commercialized not only alkylation, but something else also, dimerization. So, how do we describe how catalysis went nano first? Like everybody knows, if gold is not nano, it doesn't work. And of course, an ancient Ayurveda people knew that Swarna Bhasma doesn't work unless it is nano, which people discovered after a long time. But nano is past. Now we are talking of atom. Atom catalyst. How this whole business of science, one of the good things about catalysis is people have gelled together from all disciplines, physics, chemistry, material science, chemical engineering. If you see the papers that appear, they come from all these groups. And how spectroscopy has made such a world of difference in catalysis, I think many people may not remember. First time online spectroscopy was used, infrared spectroscopy, was platinum rhodium gauze for ammonia oxidation to NO. Why the catalyst goes FUT? This was online infrared spectroscopic measurement, goes long back. Today, you can see atoms walking. And this phenomenon of surface diffusion is something people thought it was figment of imagination. And therefore, I quote the first example, I saying how you do magical changes. And I have this habit of always taking syngas as starting point. How I can do complete selective conversion to methane, how I can turn around, convert only to methanol, how I can convert it to all the way to diesel. If diesel is formed, obviously it is methylene group undergoing surface diffusion. So this is an eloquent proof of how surface diffusion affects catalysis. It's not over. Now we are operating the Fischer-Tropsch in petrochemical mode. So you get pentene. See, ethylene oligomerization can only give you even number. But Fischer-Tropsch can give you pentene 1, hexene 1 commercially. Sasol is the leader in that. Only place from where pure pentene 1 is available in large quantities through Fischer-Tropsch. You get alcohols. So here is an example that you turn around and the story is not over. How you will be able to maximize alcohols. In fact, I see very recent papers how higher alcohols can be made from syngas. Now it will change fundamentals of business. What catalysis does is change fundamentals of business. So this is one. The classic example that how you get and turn around completely the selectivity. Propylene oxide can be selectively isomerized to allyl alcohol, done on a grand scale by Leondel. You can convert propylene oxide to propanaldehyde completely selectively. And of course, not that you want to do, but you can also convert completely selectively propylene oxide to acetone. In the contemporary part and loyal to your subject of sustainable development, so many things are being done for glycerol because 10% of biodiesel is glycerol. It's a different matter whether biodiesel will really go places. I have very strong opinion. It hardly will make some kind of a little dent here. But that also depends on catalysis. But this glycerine has been turned around in so many ways that it shows wonders of catalysis. What can you do? You convert glycerine to 1,2-propanediol, one way, 1,3-propanediol, acetol, glyceric acid, I can name some more, all through different catalysts. Same molecule, very different, not potpourri of products, but selective conversions. Isn't that wonders of catalysis? It is wonders of catalysis. Like that, there are examples after examples. You take, for example, just like I gave you propylene oxide, same thing applies to styrene oxide and all. You can go to phenylacetaldehyde or you can go to acetophenone. So catalysis chemical industry will collapse without catalysis, because there is only one large scale process which is non-catalytic, where there is also heading for being catalytic, it is naphtha cracking, ethane cracking. They are the only ones which are practiced on a large scale which is non-catalytic. I used to call, when I used to teach this course, free radicals in action. That when you do naphtha cracking, you have brilliant example of free radicals in action. You call them also as catalysts, free radicals. Now, what has happened in the recent past, because of strong scientific background, particularly varieties of spectroscopy, every type of spectroscopic method has been used to decipher many things in catalysis. And when you look now for sustainable development, in fact, if you go historically also, look, when first breakthrough came for ethylene to ethylene oxide, catalytically bypassing the chlorohydrin process, this was an outstanding example. Of course, this was preceded earlier with contact process, sulfuric acid. I am trying to be loyal to your topic. See, what was the selectivity? 60%. Where are we today? 84%. In fact, some theory, there is a theory, and people are saying that theory is going to fail. They may cross even 85, 86% selectivity to ethylene oxide. Now, how much is the reduction in CO2 emission? When you say selectivity is 60%, rest is all gone to carbon dioxide. What kind of, every mole of carbon dioxide, 94 kilocalories. What happened when malic anhydride was made from benzene? 2 carbon atoms went to carbon dioxide. Today you do it from butane. What happened to phthalic anhydride when it was made from naphthalene? 2 molecules went to carbon dioxide. Today you do from orthoxylene with such high selectivity. So this is how catalysis makes an impact. When homogeneous catalysis comes, since RV is here, I must say something about homogeneous catalysis. It led to Nobel Prize, Wilkinson. But how chemical engineering added to coordination chemistry was when you introduced their biphysics system, so the recovery of rhodium became very, very facile. But there is a story about this which many people do not know, that Monsanto had actually done a lot of work. And I want to quote this example to show that how board of directors cannot choose something very original. So this homogeneous catalysis work of Monsanto was rejected by the board. They didn't commercialize. Someone else. In fact, many of you may not remember, one of the greatest development in history of catalysis, apart from everybody says Haber was the greatest and got Nobel Prize, but I still rate platforming as during wartime, as one of the greatest developments in the history of catalysis. I mean, imagine hexane being rolled up to cyclohexane, then converted to benzene, all in one step. Isomerization, dehydrogenation, my God, I mean, if you look at it, we will find it very hard to believe that a platinum noble metal based catalyst can do this, and still nobody has found a substitute for noble metal. But why I quoted this was, when this was presented to UOP board, they rejected. He said, look at this, Johnny, crude oil was less than $1 a barrel. Yeah, they want to use noble metal catalyst. How great was this work? We wouldn't have had benzene, toluene, xylene today, but for reforming. And then both Epatif and Hansel are in Hall of Fame in Washington. So great is this. This is how wonders of catalysis. But coming back to Monsanto, they came back with revenge. All the knowledge that they had on homogeneous catalysis with rhodium, They came out with methanol carbonylation and acetic acid. And brand new acetic acid plant, high pressure technology of BSF was dead on day one. Just as acrylonitrile plant, brand new plant based on acetylene was dead on day one when propylene ammoxidation came. And one night, the price of acrylonitrile dropped from 33 cents a pound to 11 cents a pound because propylene was dirt cheap. Brand new plants, both these cases. ICI, which invented naphtha reforming, was a very interesting development. In fact, they had already put up an ammonia plant. I'm witness to that plant in Bellingham, partial oxidation. And they developed naphtha reforming. Very interesting. Many people may not know what was the trick by which carbon deposition didn't occur on the catalyst. The reforming up to propane, butane worked very well. Anything beyond butane, the catalyst was unstable because there will be carbon layer. And there was ancient literature that coal gasification is catalyzed by alkali. So all Sid Andrew did in ICI was he put mobile alkali, potassium, and naphtha reforming became. By the time they perfected this, North Sea gas was discovered, and all their plants switched on to methane and naphtha reforming. But naphtha reforming became very relevant because even in India, first, and when natural gas was made available and whenever there was shortage, they put a precursor to convert naphtha only into methane, ethane. And you could then use the conventional methane reforming unit. I want to finally say something about how this science is changing so well in this area of, I referred to atom, and how you are able to reduce. It goes back in early days, but today it is even so much smarter that you can have on the support noble metal catalyst going down to levels of 0.2%, when earlier 1%, 2% used to be used. It's a remarkable development only because of science of that you are able to put them at nano level. So in this context, I want to give one or two more examples to say how it has benefited society in so many ways, not only ammonia and all, but this automobile exhaust, three-way. Just see the wonder of, and it's a matter of pleasure, one of our UDCT early graduate was associated with a automobile company in the development of this three-way the catalyst. How one is able to deal with automobile exhaust, and we are still struggling for the diesel exhaust, but for gasoline exhaust it's working very well. The way this field is going to develop, so I want to say, where are the challenges? I think this science has developed to a level that I see hope in methane going directly to methanol, not via syngas. Just as I think our Paul Ratnaswamy, Mr. Catalyst, I call him, he had long time ago propane oxidation. But propane going to propanol, isopropanol directly, you can't rule. There is a good chance that it will happen. And of course the dream process, what big way you will have sustainable development if hydrogen peroxide could be made by reaction with hydrogen and oxygen. So many papers have come. There is a good chance that this might happen with the science, development in science of catalysts. But hydrogen peroxide production itself has seen dramatic changes. And today, your propylene oxide from propylene plus hydrogen peroxide is one of the finest sustainable process. All that hydrogen peroxide leaves is water. So hydrogen peroxide is Mr. Clean. When somebody asks a question, suppose we have no crude oil, would you still have fuel? Answer to that is yes. But don't ask the cost. Because as long as we have food, we will have agro waste. If we have agro waste, there are so many ways by which you convert. You can do pyrolysis, you can do this, you can gasify it, you can do anaerobic and get gas, and from that gas you can do anything you want. From methanol you can make olefins, and then you can make aromatics from methanol. All this is possible. But costs are abnormally high. You know the cost of 2G, what is the cost of alcohol from it's not that you cannot produce, it's question of cost. But my favorite topic is one thing which will always have, without fail, in the agro waste, lignin. Just as many years ago we were championing sucrochemistry, I am great champion of lignochemistry. Look at the versatility of, and in last 5 years I must have read not less than 50 papers, if not maybe more, of converting this into whole host of chemicals, phenolics, all kinds of phenolics. How you can transform, a catalyst is going to play a big role in this to get specific end products from look at the quantum of lignin that is available. I mean, if you take only sugarcane crop in India, from the bagasse, the amount, after bagasse has been used for cogen, at least 20-25% can be spared in any efficient sugar factory. Even if you take that with 35 million tons of sucrose, so something like 300 odd million tons, take out the water, look at the quantum that will be available at 15, 16, 17% of the dry mass, or more even. This is one. But this great penchant about non-edible oil being converted to value chemicals, glycerol, quantities are very small. If India imports 60-65% of edible oil, which non-edible oil is available today? We had this great castor oil. Castor oil today almost same price as groundnut oil, 120 rupees. And castor oil was converted to two range of products differently. You made nylon 11 from undecylenic acid. You made sebacic acid by alkali part. You make nylon 610. But how much is the quantity that you can have? So if I have nylon 11, I can have nylon 12 just from butadiene. That itself is a very interesting catalytic process. I can selectively dimerize butadiene to vinyl cyclohexene, or I can selectively convert to cyclooctadiene or cyclododecatriene. And the science of catalysis is so good that I can selectively hydrogenate cyclooctadiene to cyclooctene. Stop there, not go to cyclooctane. Just as what Asahi had done was selective hydrogenation of benzene to cyclohexane. Isn't it a wonder of catalysis that you are able to, even though selectivity is still not as great as one would, but commercially selective hydrogenation of benzene to cyclohexane is being done. So sustainability is not possible without catalysis. You look, if you want to cut down CO2 emission, which is one of the biggest villain in terms of climate, catalysis will play a very big role. I can keep on enumerating to you many interesting examples, both on the science and practice of catalysis, but I'll restrict myself to the time that was allotted to me. I wish Raja was present, that many of these, he did start the work at my prodding on glucose to be converted to a mix of propylene glycol, erythritol. He did publish it. I think he published one paper also on that, isn't it? The hydrogenolysis of glucose, he published some paper, no? That is still because as long as you have cellulose, you can always get glucose. And glucose can be converted to whole range of, I am not only just talking So you take last the wonders of biocatalysis on one side and wonders of electrocatalysis on the other side. What biocatalysis will do, my God, it will really transform chemical industry. If you take this directed evolution work of Nobel laureate Francis Arnold, I tell you, and it's a pity that in India we don't have expertise in bio. I think I would urge you people in catalysis to train people in directed evolution. It will revolutionize chemical industry. I mean, you kind of things you will be able to do, make optically active molecules. Electrocatalysis, it all started with caustic chlorine in a big way. When the anode was catalyzed, ruthenium, how it transformed caustic chlorine production. There is a revival now because you have renewable energy available. Electrocatalysis will go places. Biocatalysis, electrocatalysis are the new emerging areas which deserve. We don't have a single electrochemical process developed in India for organic transformation, nor do we have a single novel biocatalytic process developed in India. These are the challenges. I leave you with all, but I want to conclude by saying that even to date, on and off, many of my colleagues and friends will know that I miss Raja, and I once again pay tribute to his genius. Thank you.
Thank you very much, Professor Sharma, for enlightening address and for setting an inspiring tone for the day's proceeding. I would request Dr. Shrikant Karwa to present a memento to Professor M.M. Sharma. Thank you, sir. I would request Dr. Deepak Palekar to present a memento to Professor J.B. Joshi.